Well, let's talk about this chart. So I know it says class 0, 1, 2, 3, 4, but these in most scenarios, these would be like product classes or some sort of end result to a process, to a sales process, to a production process, whatever, right? So the business might dictate to you what they need out of this, right? So let's take class 3, right? Class 3 is properly classifying 393 of the 400 items that are in that data set, okay? And you know that the accuracy here is 91, the loss is a little shaky, right? We've already agreed on that, right? But the business might come to you and say, that's fantastic. We want this model. And they're going to tell you that they want the model because these, any number that's not in the 393 is basically a mistake, right? And the business might tell you, well, every time you properly tell us this, we make $500. And every time we make a mistake, we lose $3,000. Right? So we're ecstatic that you're only making 4 mistakes. Like, that's great. And then you're going to say, but wait a minute, this model really stinks for class 2. And they're going to say, that's okay, because these mistakes only cost us $10. Right? So we're okay with a model that's optimized for class 3 because that's when you're saving us the most money and you're making us the most money. Right? So it's totally okay, for you to make those adjustments. It will be like literally dictated to you to say, I don't care what the model looks like. I don't care what you use, Keras, PyTorch, a room full of monkeys. Just don't make mistakes in class 3 because those are really expensive mistakes. Like, I've been in situations where that happens, right? Like, you can sit there and you can break it out and actually assign values to your mistakes. And then sometimes the outcomes themselves have probabilities. So you got to do, these expected value formulas, blah, blah, blah. But you can sit there with the business and they will tell you that I don't care about the accuracy. I just care that you're not making a mistake here because that's where our money is, right? So Rahul, you're asking a great question, but it's not always an academic exercise. It's not always a black or white answer. Like, it will be dictated to you and there will be some hard numbers behind it. Like, some very logical numbers behind it. Right? So yeah. So that's really my best answer to you. So Leo says, yes, but achieving a higher accuracy without overfitting is a heck of a challenge. Yeah, but it might not matter in that scenario, right? It may or may not matter in that scenario that I'm telling you about. Again, they can assign dollar values to all of these. So they might be okay with an overfit model that optimizes for class 3. Because again, those mistakes are very expensive. And they could tell you, hey, right now we're making 50 mistakes a day that cost us $3,000. If you're telling me you can only make 4 mistakes that cost us $3,000, we love you, right? They're going to love you for that. And again, they don't even care if it's Keras, PyTorch, or a room full of monkeys. They just don't want mistakes in class 3. And they're okay with mistakes in class 2 because those are the cheap mistakes. So it just depends. It just depends, guys. That's the real world stuff that, even the academics don't have a good grip on. Right? Because in academia, they want perfection, right? Don't overfit that model. Give me a model that meets X accuracy. Well, that's not always the real world. That's the academia world, but that's not the real world, right? And again, I'm telling you this because I've been in those meetings where we will sit there and we will say, okay, well here's the cheap mistakes, here's the expensive mistakes, and that's where we want you, Dennis, you, the data science team, to go in that direction. And then Leo, as far as like how do you actually achieve that? You know what? Sometimes just Monte Carlo it, right? You can Monte Carlo this. You'll have to set up a process. You'll have to monitor your outputs. You monitor your accuracies, monitor your confusion matrix specifically for the class that you're interested in, and just let the processor fly, right? And then eventually you'll come across a model that meets those needs of saying, this is your best outcome for the business, not for academia, not for perfection, not because it's the best accuracy or F1 score or whatever, but because it's what the business needs. Rahul, so the follow-up from Rahul, so you are saying that whether Keras result is better or PyTorch depends on the business problem, and always the last epoch is the final version of how the model will perform for the new data. Okay, you're asking two separate questions there. But let me take on the business problem side because I want to stay on this topic. So the purpose of today is more to show you like the differences in how the models come together. We've already seen some of the differences in the code, things along those lines, right? That's really kind of the purpose of today. So I'm really not trying to say, oh, for this business problem, Keras is better. For that business problem, PyTorch is better. When I'm talking to you about, the losses and the confusion matrix and the mistakes, I'm saying that agnostic of any neural network design or tool that you might use, right? I'm using that to give you the real world view, right? Because this is how neural networks, or really any model, is used in the real world, right? And the real world is not about perfection; it's about the business impact. And that's how you will measure business impact sometime. You can make, the business will tell you, you can make a mistake here, but don't you dare make a mistake here. So that model isn't going to have perfect accuracy numbers, right? But that's okay because that's what the business requires. That's the request that has been made to you by the stakeholders that you serve, right? I mean, ultimately, that's what we do. We serve our stakeholders, right? So Rahul, I'm trying to present all of this independent of tool, right? Rex says, so the value behind recall precision and accuracy are contextual. Absolutely, Rex. Yeah, absolutely. Yeah, and we've talked a little bit about this before, as far as like the precision and the recall, right? I think I know some of you have heard this, but there's a lot of people that are new. The example I've given before is like a credit card transaction, detecting fraud, right? So there's two mistakes you can make there. You can let a fraudulent transaction go through, or you can block a legitimate transaction by a legitimate customer, right? Completely different costs behind those, right? If I'm a legitimate customer and I get my transaction declined, what does that cost the credit card company? It costs them an annoyed customer, right? I'm annoyed, but I'm probably not going to cancel my credit card over that, right? If I'm a fraudster, and they let my transaction go through, credit card companies can assign what the average value of a fraudulent transaction is, and they can say every time that mistake happens, we lose X number of dollars, right? So huge imbalance there in the costs, right? So yeah, I mean, and I'm saying that to Rex's question, that's a precision recall problem, right? but it's clear which one you want to optimize for, right? Like that's 100% clear which one you want to optimize for. An annoyed customer, on an average basis is not going to cost you a lot of money. Like, yes, some non-zero percentage will cancel their card, but like 1 in 1,000, right? So the cost on that is very little to a credit card company. But they know how much an average fraudulent transaction costs them, right? In real dollars. So yeah, so yeah, Leo, excuse me, Rex, it's all contextual, right? And like I say, a lot of the times this will be dictated to you. And that's okay. Real world data science is not about perfection. It's about serving your stakeholder. Perfection in models. I mean, obviously you want to do a good job, guys, right? But it's not about perfection in models. It's about serving your customer in the best way possible. So Rahul says, so how can you optimize your model for a particular class? Sorry, this is out of scope. We're going slightly out of scope, but I don't mind having this discussion because it's an important one, and because really, again, realize guys, we're talking about data science in general. We're not even talking about neural networks, and certainly not PyTorch or Keras specific. This is just, data science overall. Stakeholder management. But Rahul, there's not always a way to do it. The way to do it is that you're going to have a process where you're going to try a bunch of different models. Basically you're kind of Monte Carloing it. You're going to set up, your monitoring systems in the background to look at the metrics of each model as they finish training. And then you're going to say, oh, that model has a great accuracy for class 3. So let me go ahead and save that model. And then that you would call like your champion model candidate and say, oh, okay, cool. Now, you're getting there because you're trying different hyperparameters, maybe different model designs, different activation functions and things like that, right? But that kind of doesn't matter, right? That's kind of like why you're Monte Carloing, because you don't know what the answer should be, right? But whatever that model ends up being, if you can go back to your stakeholder and say, hey, look, we developed this model. This is what the confusion matrix looks like. This is how many mistakes that one class is going to do. These are the mistakes in the other classes. What do you think? How do you feel about this? And they're going to tell you, right? Leo says Monte Carlo is a probabilistic model for those a bit lost. Yeah, sure. Yeah. I know that's the popular way to think about it, but honestly, Leo, I just think of it as brute forcing it, right? How do you get the right answer? You try every answer. Right? I mean, that's kind of like the dirty secret of Monte Carlo, right? Like, I think they gave it like this fancy sounding name to make you feel better, but you're just brute forcing it, right? I mean, that's all it is. You're setting up all your parameters, you're setting all your loops to try those parameters, and you're just letting it fly for the weekend, right? You let it go on a Friday afternoon, you let it fly, you come back on Monday and see what happens, right? So yeah, technically speaking, it's a probabilistic model developed, back, I think in the 70s or something, but you're just brute forcing it. Shut up. Put your academic books away. You're just brute forcing it.